Ali. Well, that's the way we say hello in Palau. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, this picturesque place that you get to see is Kayanjal Atoll, Orukai, Palau. This is a Pacific gem which is an untouched paradise and has a population of just 54 people by the census of 2015. This is a ring-shaped coral reef which surrounds the lagoon. Palau is a beautiful archipelago which has 200 limestone and volcanic islands. Make sure to visit this natural beauty, have a nice time here, and also make sure to have pizzi, which is the famous sweet dish here. Do look up for dolphins and turtles, and also tell all the people of Palau that you get to meet Ali. In this note, children, I'm going to say Ali again, but this time it is to indefinite integration. Now first I'll give you a little briefing about what indefinite integration is, and after that we'll be looking up a few formulae, and then further we'll be looking up an interesting sum. So always remember, children, that whenever we are talking about integration, I'm sure you will very easily be able to tell me the literal meaning of this word. Yes, Nida. It is to bring together. Very good. That is the reason why we have national integration program. That means we have the people of all tribes, religions, regions to be brought together. And if you talk about the Indian Railways, or if you talk about the national of different sports, they are all national integration programs. Okay, so here also in mathematics, when we try and get the original function back, we call it to be integration. Now, how is it that the original function was lost? That is because initially it was differentiated. Now, what is differentiation? When you talk about the change in the value of the dependent variable, that is y, with respect to the change in the value of the independent variable, that is x. When the change in the independent variable is infinitesimally small, you call it to be differentiation, right? And the reverse process of differentiation is integration, right? And why is it indefinite integration? The reason is that here we are talking about the integration without any limits. For that matter, if you have a function which say is graphed, then it is graphed in an xy plane. Then obviously there are limits between which a function is graphed. But if suppose there are no limits, then you will call it to be indefinite. And here when we are talking about this integration, this has no limits, and that's why we call it to be indefinite integration. Right? Now, children, coming over to a few formulae. So if say we talk about integration, like I already told you, it is the reverse process of differentiation. So when you had certain functions and you differentiated it, whatever you got, that when integrated will give you the original function back, right? So here thus, when we talk about the integration of cos x dx, then that will become equal to sin x plus c. Now remember, children, this c is the constant of integration. That is because when a constant is differentiated, you get 0, because there is no change in the constant with respect to the change in the independent variable. And there is no way we can bring that constant back. That is the reason this plus c is the constant of integration, right? Which is always written added to a function, although it can even be negative. Okay, so the next formula is when we talk about integration of sin x dx, then that will become equal to minus cos x plus c. I'm sure you're able to relate. When we talk about the differentiation of cos x, that becomes equal to minus sin x. And since there is no minus sign on the left hand side, that is why you bring up this minus sign on the right hand side. Now next is when we talk about integration of sec square x dx, then that will become equal to tan x. The reason being the differentiation of tan x was sec square x. Now children, if we talk about the integration of minus cosec square x or just cosec square x dx, then that'll give us minus cot x plus c. So here children, if the integration would have been of minus cosec square x dx, then the integration would have been just cot x plus c. But because you've taken the left hand side to be positive, that is why on the right hand side we have to bring up a negative sign, as the differentiation of cot x was minus cosec square x. Now next children, after this we have sec x tan x dx. So this is equal to sec x plus c. Lastly, if we talk about integration of cosec x cot x dx, then Nida, how much is this going to become? Yeah, very good. That is the reason when you said you wanted to become a scientist, I said that you would probably be able to be, because you have a good memory, you work hard, and that is something which is very good and it is exemplary for all. Okay, so this is going to give you minus cosec x plus c. So children, these are the few formulae. All of these concepts I'll just quickly discuss, and after that we'll be coming over to the sum. Now children, here we are talking about integration. Integration is trying to bring the original function back. That is because when we had a function f of x and we found out f dash x, that is the derivative of the original function, we talked about change in the value of the dependent variable with respect to the change in the value of the independent variable when the change in the independent variable is infinitesimally small. Now this looks to be very large and a little difficult to understand, so I'll quickly show this to you, that if say you talk about some f of x which is a function, and say you want to differentiate this, that means you want to talk about d upon dx of this, then here children we have here limit delta x, or the change in the value of the independent variable, to be very small, that is infinitesimally small. Then if we talk about f of x plus delta x, from which is subtracted f of x, right, and this if say is divided by delta x, then this is actually change in the value of the dependent variable. As always, whenever you have f of x, you will get y. So this is actually y2, a later value of y, and this is y1, an earlier value of y, and this is divided by delta x, that is change in the value of x. And obviously this must have come into existence when you would have done x2 minus x1, right? Only then you will be able to get by how much is x2 more than x1, right? So this is the change in the value of the independent variable in the denominator. When we are talking about the change of the independent variable to be infinitesimally small, we call this process to be differentiation. Before integration, I'm sure you people must have already studied differentiation, and in differentiation you found that the functions somehow changed, right? And here in integration we will try to bring the original function back, right? Now this is indefinite integration actually. That is because we are not going to talk about any limits, right? Because normally whenever you talk about a function, say, then what you do is you actually talk about graphing the function, say something like this. Let's say this be the x-axis and the y-axis, that is the xy plane, and let's say we talk about the graph of a function. So I'm sure you're able to see this, that we are drawing the graph between two values of the abscissa. This is one value, and then we talk about the other value of the abscissa, which can be seen somehow like this, right? So these are the two values, probably some x is equal to a and some x is equal to b, between which we are looking up graphing the function, and thus there'll be other phenomena which is going to be linked with the graphing of the function. But if we are not interested about these limits x is equal to a and x is equal to b, this can go on up to infinite length, then we call it to be indefinite integration. So indefinite integration is the thing that we are studying at this time, and we have discussed a few trigonometric formulae which actually have originated from the differentiation of these entities which are on the right hand side to have got these to be the derivatives. Right now, from the derivatives, we are trying to get to the original function. Is everybody clear? Good. Now, children, when we talk about integration of cos x dx, then that's equal to sin x plus c. When we talk about integration of sin x dx, then that's equal to minus cos x plus c. Now, when we talk about integration of sec square x dx, then that's equal to tan x plus c. If we talk about integration of cosec square x dx, then that's equal to minus cot x plus c. If we talk about integration of sec x tan x dx, then that's equal to sec x plus c. If we talk about cosec x cot x dx, then that's equal to minus cosec x plus c. Now remember here, children, that this plus c is because if in the process of differentiation you would have had a constant like say 4. Let's have an example. Let's say you are talking about d upon dx of say x raised to the power 4 plus say 41, right? And now, children, if you were to differentiate this, I'm sure you people know that the derivative of x raised to the power n will be n times of x raised to the power n minus 1. As such, this is going to be differentiated to be 4x cube, and as the derivative of a constant is 0 because it doesn't change for the change in the values of x, and that is the reason why it will become 0. So only 4x cube will remain. And if you have only 4x cube, how will you be able to imagine that earlier along with this was a constant 41? You can probably think it's 410, or probably you can think that it was minus 14, right? And because you can't imagine it, that is the reason why plus c as a constant is kept here. In humor, you can say that these are actually flowers for the dead functions which have been differentiated, which have been kept here, right? Okay, now children, here after this we will now be discussing a sum. So this is a question which I like you people to quickly try, and after that then I'll be discussing the question with you people. Himanshu, I can hear you murmuring. This is the time when you need not make your eyes move, but you should make your head move. You should make the way you think that move, so that you can try and think what the solution of the question can be. Okay, all those children who are studying offline can pause this lecture for a longer duration of time and take it a better try. Okay, so here children, we've been given one thing, that is we have to find out the primitive. Now, does anybody know what primitive is? Obviously, you can assume, like I know, Nida, that you must be thinking that the integral is what you want to find out, right? So when we find out the primitive, we are actually interested in getting the original function. So we have this integral which will get solved in such a way so that we will get the original function, right? So this is just a way of telling solve the integral. Okay, now children, here we get to see in this question that we have integral of dx upon 2 sin x plus 3 cos x whole square. So here children, as you see that there is a binomial in the denominator, right? And there is also a square, and if the square is opened up, it will become a trinomial. Our task will be first to make this a monomial, right? So how do we make this to be a monomial? Let's see how we can do it. If say we write this to be dx, which is divided by sin x, right, and multiplied by 2 divided by the root of 2 square plus 3 square, right? And to that is to be added here 3 cos x times of 3 upon root of 2 square plus 3 square, right? And obviously there is a whole square of it, and we're going to write it, right? So as here within root you'll be getting 4 plus 9, that is root 13, right? And this root 13 on getting square is going to become equal to 13, which will come over in the numerator. That is the reason why we will be dividing by 13, right? So that there is no problem in bringing up this change. Now children, after this there is another thing which is to be done. That is, now you can talk about this 2 upon root 13 to be, say, some cos alpha, and 3 upon root 13 to be, say, some sin alpha. So this is the thing that we're going to now write. So we have 1 upon 13 times of integral of dx divided by sin x cos alpha plus cos x sin alpha. Yeah, obviously if you want 2 upon root 13 to be written as sin alpha, even that you can do, because even that has a formula sin alpha sin x plus cos alpha cos x, right? So here now children, we have a square of it, and that we are going to now write. Now we will quickly be reminded about compound and multiple angles, where there was a formula. That is, if you talk about sine of a plus b, then you have it to be sin a cos b plus cos a sin b, right? So here also, as you can see, this is sin x cos alpha plus cos x sin alpha. So this just resembles the formula that you studied in compound and multiple angles, and thus in its place you can now substitute the value. So this now is going to become equal to 1 upon 13 times of integral of dx divided by sine of x plus alpha. And remember children, we also have a whole square of it. As such, we will write a square. Now children, what about alpha? Now let's quickly look up what we can do about alpha. So just see that we considered that 2 upon root 13, right, was cos alpha, and we considered 3 upon root 13 to be sin alpha. So if, say, we now talk about dividing, say, the second equation by the first equation, right, something like this, then what will we get? We will get sin alpha divided by cos alpha, which obviously is going to become equal to tan alpha, and on dividing, here we'll get to see that root 13 will get cancelled from the numerator and from the denominator, and then the value of this is going to come to be 3 upon 2. Now for the children, we can also say this, that alpha will thus become equal to tan inverse 3 upon 2, right? So this is the thing that you will write here, right, where alpha is equal to tan inverse of 3 upon 2. Now children, after we have this, next now what we're going to do is we will write this to be 1 upon 13 times of integral of dx divided by sine square x plus alpha, right? And since we have a square of this, right, when it'll go over to the numerator, that is sine square theta, when it'll go over to the numerator, it'll become cosec square theta, right? So as such, here we have sine square x plus alpha, and since you know that 1 upon sine is the same as cosec, so as such, here we will have 1 upon 13 times of integral of cosec square x plus alpha, where alpha obviously is known to be tan inverse of 3 upon 2. Now children, next here what we do is we can write this to be 1 upon 13 times of minus cot of x plus alpha, right? I'm sure you people remember that we have done this formula just now, and I'm sure you people have not forgotten this so soon. That is integration of cosec square x dx is equal to minus cot x plus c, right? So this is the formula that we've applied here. Now children, here when we have finally integrated, then obviously after this we should be writing the constant of integration, and we write it like this, and this becomes the final answer, where you can say that you are talking about alpha to be equal to tan inverse of 3 upon 2, right? So children, now all of this I will just quickly discuss, and if there is any doubt whatsoever, don't be reluctant, ask it 1,000 times. I'm there to help you out. Now children, in the question you have find the primitive. Primitive means you want the original function which was there before differentiation, right? That means you have to integrate this function. So this is just a synonym of saying this. So integration of dx upon 2 sin x plus 3 cos x whole square can be written as dx upon sin x times of 2, right, plus cos x times of 3. However, here what we're going to do is we will also be dividing by the root of, the sum of, the squares of the coefficients of sin x and cos x. Now coefficient is what? It is the number which is multiplied, right? So 2 is the coefficient of sin x and 3 is the coefficient of cos x, right? And thus here if you do this, then we will have this as 2 upon root 13, right? And plus here multiplied with it is sin x, and plus cos x times of 3 upon root 13. Now Nida, can you tell me why is it that we have divided by the root of the sum of the squares of the coefficient of sin x and cos x? Why couldn't we have done with just 2 and 3 which was given here? If you can tell this, I will give you a dairy milk fruit and nut. Anybody from the class? You want some time. So that much amount of time I can't give because out of the class there are many resources. Okay, so here I'll tell you, look, if say we talk about sin x, remember children, sin x always varies between -1 and 1, right? And similarly if we talk about cos x also varies between -1 and 1. And thus how is it that you will be able to consider cos alpha to be 2, and how is it that you will be able to consider sin alpha to be 3? And that is the reason, to make it a proper fraction so that it falls in this range, be it for sine, be it for cos, what we do is we divide by the root of the sum of the squares of the coefficients of sin x and cos x. Do remember this. This is a very important step, and the reason of this you should be knowing because it can be asked obviously in any reasoning type of a question, especially in competitions. Okay, now children, here as we will get this 1 upon root 13, and when it comes out of the square it will become 1 upon 13, which obviously on reciprocation will become 13 multiplied with dx. So obviously we should also have 1 upon 13 so that both of these get cancelled, and that is the reason why we have this 1 upon 13 outside. Now children, what we have done here is we have considered this 2 upon root 13 to be cos alpha, and we have considered 3 upon root 13 to be sin alpha, right? You can consider this to be sin alpha, you can consider this to be cos alpha, then things will become a little different. Excuse me. Now next children, here we get to see that if we talk about sine of a plus b, a formula in compound and multiple angles, we get sine a cos b plus cos a sine b. And this is something that we have here, sin x cos alpha plus cos x sine alpha, right? And we also have a whole square of this, right? And thus we can say that we have sine of x plus alpha just by the above formula that we had in compound and multiple angles, and a square of it also. So thus this is going to become sine square x plus alpha. Now if you talk about the inverse of sine theta, that becomes equal to cosec theta. As such, this will become 1 upon 13 times of integral of cosec square x plus alpha, and obviously there has to be a dx which is multiplied with this. Now children, after this what we do is we quickly remember the formula that you had when you talked about the integration of cosec square x dx, that's equal to minus cot x plus c, right? And that is the reason why here we will have the integral to be minus cot of x plus alpha, right? Obviously that's already multiplied by 1 by 13, and to that is to be added c. Now what is alpha? For that, what have we done is we've considered this 2 upon root 13 to be cos alpha. Alright, and we have considered 3 upon root 13 to be sine alpha. Now, if we divide the second equation by the first equation, we will get tan alpha to be equal to 3 upon 2. Alright, and thus alpha can be written to be equal to tan inverse of 3 upon 2. And this is what we keep writing along, because from where has this alpha come? This can be a question, so we should be ready with the answer. So alpha thus becomes equal to tan inverse 3 upon 2, which you require to write at the end when you're writing your answer. So when you have 1 upon 13 times of minus cot of x plus alpha plus c, where plus c is the constant of integration, you will say what alpha is, that is, it's equal to tan inverse of 3 upon 2, right? And obviously we've been able to do this because of this formula that we had in integration that we just studied. So is everybody clear about all of this? Sure? Nida? Himanshu? Everybody clear? That's good, children, and that is all that I have for you people in this lecture. Do write to me how you like this lecture, what you want me to teach next, and how is it that you can score 100 marks, right? That I'm sure is the end target, and mark my words, this is not a tough task. If it is done in a proper way, under the guidance of a coach, getting 100 is something which is very simple, and along with it you can also prepare for the competitive examinations, right? So make sure that there is a link which will be there in my description, and there's also my email ID. So if you want to get in touch with me, so obviously you can write your requests, what are the next chapters, what are your problems, in my email ID. And also there will be a free course for you to which you can subscribe the moment you click on the link which will be there in this lecture's description. So bye, children, hoping to help you people more. Bye.